Hi, my name is Richard Averitt. I work at UC San Diego. I'm a professor in the physics department. My area is condensed matter physics, and I use lasers to study the properties of materials. I've had a great working relationship with Quantum Design, and I started working with them in terms of incorporating the Versa Lab into our undergraduate curriculum here. And so that Versa Lab has been running for the better part of 8 years with almost no problems at all. So it's natural then that in terms of having magnetic fields, that this OptiCool opportunity arose. In terms of the research we've done in the OptiCool up to this point, it's been primarily what we would call all optical pump probe spectroscopy, where we're bringing in different beams kind of in the visible or near infrared range. But a lot of my research over the years has been in the far infrared or terahertz, and so I think that the OptiCool provides a really exciting opportunity to do novel far infrared spectroscopy on materials in a magnetic field environment. OptiCool has really nice optical access, because the sorts of experiments we do, we have to bring in multiple optical beams to be able to excite a sample and then probe these dynamics in a time-resolved fashion. The magnetic field, that allows us to tune the properties of the materials and then look at the dynamics of the materials that we're studying as a function of magnetic field and of course as a function of temperature. So just the ability to have these degrees of freedom when we're doing these kind of dynamic studies of quasi-particles and things like that inside of solids, it's very powerful. The automation of the OptiCool really facilitates these measurements, and in fact the first student who started working with this when we had it installed, he really quickly integrated the OptiCool software with our data acquisition software that we use for these optical measurements, and so everything became very user-friendly. We can just take continuous data and really get high-quality data, run overnight, and just really get more data per unit time than we'd be able to do if the software wasn't so easy to use. I had fantastic response and excitement from colleagues at conferences and other, I give a lot of talks at university, and so when I describe what we're doing with the OptiCool, there's certainly been a lot of interest and excitement. Over the past several years, I've talked to a lot of colleagues and collaborators, and actually even former students who have also adopted the OptiCool for their research. And what's really exciting about it is the versatility, right? Because I do my thing, but of course the amount of research that's going on using magnetic fields is much broader than what I do. And so it's really fantastic to see these other groups implementing the OptiCool in completely different ways to do their research.